Okay, so here is your Unit 4 review video. If I scroll through, these are the problems that are going to be covered. I got some requests for the parabola video using the definition, so I'll actually start with that. So that's question 9, and then I'll just go through, and I picked out about 11 problems to go through for you guys. So starting with number 9, because this is the one that we struggle with the most, derive the analytic equation of a parabola using the distance formula. Or the definition of parabola with a focus at negative 3, 5. So I'm going to go ahead and plot this. I'll zoom in a little bit. Negative 3, 5. Here's negative 3. Okay, so this is my focus. And my directrix is at y equals 1. Okay, so I need to write an equation for this parabola in standard form. So first thing we're going to do, okay, so every point on a parabola is equidistant from a fixed point we call the focus and a fixed line we call the directrix. So first thing I'm going to do is state what my vertex would be. So remember, it needs to be in between the focus and directrix. So it's going to be over here. So this looks like a distance of 4 units. So right in between is 2 units. So this is my vertex. Okay, and I'm just going to sketch a picture of what this looks like. So since the focus is here and the directrix is here, I know it's going to open upward. And it looks something like that. Okay, so there's a rough sketch of what my parabola looks like. The second thing I have to do now is pick a point on the parabola. I call it any point P, and it's going to have the coordinates x, y. So this point, it could be drawn anywhere. It could be drawn here, it could be drawn here, whatever. It's just going to have the coordinate x, y. Okay, so now what I'm going to do is create or find the point that's going to be on the directrix. And this is what I'm going to call f prime. So it's going to be the point directly below P. Now, because I'm going directly below it, like if I were to measure in this distance or write in this distance, it's going to be perpendicular. So it's going to have the same x coordinate as whatever point I have here, okay? Secondly, it's on the directrix, so it has to have, I'll move this a little bit over, it has to have a y coordinate of 1. So that's the coordinate of the point on the directrix. Okay, so when I draw the rest of this in, the distance from PF to PF, or in the distance to PF prime, they must be equal. By definition of parabola, every point on a parabola is the same distance to the focus as it is to the directrix, so down this way. Alright, so from here now, I just have to use the distance formula. I'm going to find the distance of PF. I'm going to find the distance of PF prime. I know they must be equal, so I'm going to set them equal to each other. So that's the whole concept that's happening here, okay? So I'm going to come over. I'll zoom out a bit. Okay, so the first thing I'm going to do is count, or not count, I'm going to look at the distance between P and F prime. So I'm going to use the distance formula. So PF, and remember our distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay. So PF prime, I think I might have said PF. So PF prime, the distance is going to be, all right, so notice your x's are going to cancel. So I have x minus x squared, that's going to go to 0, plus y, plus y minus 1 squared. Okay, when I simplify, this just gives me radical y minus 1 squared, which is just y minus 1. Okay, now I'm going to find PF. So subtract your x's. So I've got x minus a negative 3, which goes to plus 3 squared, plus y minus 5 squared. Okay, So I have these two that are going to be equal. I'm actually going to FOIL out some stuff here. So this gives me x squared plus 6x plus 9 plus y squared minus 10y plus 25. Okay, so these are going to be set equal. So I'm going to move them down here, get some space. So I've got y minus 1 is equal to this whole radical. So x squared plus 6x, I'll do plus y squared minus 10y, and then 25 plus 9 is 34. Okay, so to get rid of the radical, I have to square both sets. Okay, so I get y minus 1 is equal to this whole stuff. Or I'm sorry, y minus 1 squared. So I get y squared minus 2y plus 1 is equal to x squared plus 6x plus y squared minus 10y plus 34. Okay, you'll notice your y squareds will drop out. So now you're just solving for y. So if I add the 10y over, I get 8y is equal to x squared plus 6x, and then I have 34 minus my 1 is 33. So just using solving techniques. Okay, now I'm going to go through, divide everything by 8. So y is equal to 1/8 x squared plus 6/8. I can simplify to 3/4 plus 33/8. So then this is the equation of your parabola. Okay, so the whole idea there, again, is that you know that no matter where this point is, it's going to be the same distance to the focus as it is to the directrix. So find these two distances using the distance formula and set them equal. Alright, so I'm going to start back up at the beginning there. So I just want to get that one out of the way right away. So let's go to question 2. Use of the grid is optional. I'm going to use it to help show you guys. I want to write the equation of the parabola given some information. So for question 2, I'm given a focus at 3, -4. So let's see. So right there, there's my focus. And I have a directrix at x equals -1. So whoops, x equals -1. I've got a vertical line going through roughly like that. Okay, so what I need to figure out then is what would the vertex be? Just like before, we know the vertex is going to be in between the focus and directrix. So let me just zoom in a bit. So I have 1, 2, 3, 4 units. Vertex is going to be approximately here, and that is at 1, -4. And because of the location of the focus and directrix, we know that the parabola is going to open in the positive direction like this. Alright, so coming back here, we know that it's opening like this. We know the vertex is 1, -4. Okay, the only other thing we need now is our p-value. P is the distance from the focus to the vertex or from the vertex to the directrix. So it's this distance in here. This is, actually I'll do it in a different color. If I use, say, let's use red. Okay, this is P. So this looks like 2 units. Also, this is P. So if I come back out here, P is equal to 2. Okay, so now I'm going to go and use the formula in the vertex form. This is going to be an x equals equation, 1/4p. And since it's opening positively, it's a positive leading coefficient. times y minus k squared plus h. Okay, keep in mind that the coordinate of the vertex is hk, so you're just plugging it in. So when I substitute in, I get x is equal to 1 over 8, because 4 times 2 is 8, times y, and then it's going to be minus a negative 4, which goes to plus 4, squared plus 1. That's the equation of your parabola. All right, so if I go down to 4 now, so I'm just going to clear this off now because I just want a clean slate here. Okay, so if I look at problem 4, I have a vertex at 2, 4. And a directrix at y equals negative 3. Whoa, that's terrible. Okay, so using the fact that this is the vertex, careful, it's not the focus, and I know it can't go downward because then it will cross the directrix, my parabola must look something like this. So it's opening upward. Okay, so it's opening up. It told me the vertex is 2, 4, and I can just go ahead then and plug it into the formula. So I know it's going to be a y equals equation, and it's going to be 1 over 4p times x minus h squared plus k. Okay, so the only other thing I needed to find was p. Now, p is the distance between either the focus and vertex or the vertex and the directrix. So if we look at this distance in here, that is 7 units. Okay, so by plugging it in, I'm going to have p equal to 7. So I have y is equal to 1 over 4 times 7 is 28 times x minus 2 squared plus 4. And that is my equation of that parabola. Okay, if you're ever unsure of what the vertex is of this form, just think about the transformations that occurred. It had to move to the right 2 and up 4. That would give us a vertex of 2, 4. So if I come down now to 5, given the parabolas, find the vertex, focus, and equation of the directrix. So graph paper, again, is optional. So for A, first thing I'm going to find is the vertex. All right, so let's just put this into the right form. So this is actually y is equal to negative 1/12 times x plus 2 squared minus 4. So like that. So I'm going to pull the vertex from the equation. This is a y equals equation. So the vertex is negative 2. It's going to be the opposite here because it's being shifted to the left. Negative 2, negative 4. That's where the down 4 comes from. Okay, I'm going to find then the p-value to help me find the focus and directrix. I know that 12, this denominator, is going to be of the form 4p. So p must equal 3. So then I'm going to go to my graph and help myself out. So I've got negative 2, negative 4. And I also know that because this is a negative, so this is a negative, it's going to be opening downward. Okay, so it's going to look like this. So that means my focus must be in here. So since I know p is 3, I have to go down 3 more units. So 1, 2, 3. This is my focus. So my focus must have the coordinate negative 2, negative 7. Right, because I had to go down 3 more units and I was already at negative 4. Now I need to find my directrix. So I'm going to go 3 in the other direction. So 1, 2, 3. So my directrix is x is equal to negative 1. All right, so now I'm going to do, I got everything right. Okay. Okay, I actually changed my mind. I'm not going to do this one because this is another y equals. Let's do the x equals equation. So First thing I'm going to do, find my vertex. Now be careful. The y is now inside the parentheses. So my y coordinate is going to be positive 6. My x coordinate is going to be 2. That's where that comes from. Now I'm going to find my p-value. So I know 8 is going to equal 4p. So p must equal 2. And then from there, I'm going to use my grid paper to help me out. So I've got 2, 6. Okay, that's my vertex, and p is equal to 2. I have to figure out which direction I'm going to go in p, though. Well, since this is a positive coefficient here, it's going to open positively like that. So this is what my parabola look like. Okay, so now using that p is 2, I'm going to go 2 to the right from the vertex. And this is going to be the coordinate, so I'm going to have the same y value, so I'm going to have 4, 6, and I'm going to go in the other direction 2 units, and my directrix is actually going to be the y-axis, so x is equal to 0. So x equals 0, and my focus is at 4, 6. All right, moving on along. Convert each of the following into vertex form by completing the square. We're going to state the transformation, state the coordinates of the vertex, and state whether it's a max or a min. All right, so looking at this, keep in mind f of x is just another way of saying y. First thing I'm noticing is that I have a leading coefficient that is something other than 1, so we're going to have to take care of that. I also like to move the 3 out of the way just so that I can help myself, accidentally not use it. So first thing I'm going to do, I'll just change this to y. I am going to move over the 3, put in my plus blanks. I'm also factoring out the 2. Just like so. Now I'm going to take half of b, so half of 4 is 2, square it, that's 4. That's what's going in my parentheses here. But I'm not actually adding 4, I'm adding 4 times 2, 4 times 2, which is 8. So that's what's going on the left-hand side. Let's clean it up. So I've got y plus 5 is equal to 2 times, and this is x plus 2 squared. Then from there, I just got to move over the 5. So y is equal to 2 times x plus 2 squared minus 5. So from here, I can pull out my vertex from these numbers. So the vertex is equal to -2, -5. Okay, so I actually went out of order. I did C. State whether it's going to be a maximum or a minimum. Well, we know that this leading coefficient here is positive, so it's going to look like a happy face. It's going to look like that. So it's going to be then a min. All right, now we'll do the transformations. So this is actually the B part. Transformations that took place, it looks like I moved to the left 2. I had a vertical stretch of 2. And then I moved down 5. So whenever you're stating transformations, just make sure you're always taking care of the up and down last. The rest of it can really go in any order. Okay. Solving a system. Biggest thing here, guys, is just to eliminate the same variable twice, so you get it down to a system where it's only 2 variables as opposed to 3. So I usually just scan, see is there anything I want to eliminate first. Nothing in particular is really screaming out at me other than I know that I have these 2 z's. So I might look there first. So I'm going to number these 1, 2, and 3 for reference. So the first thing, I guess I'm going to eliminate z. So I've got 1 and 3 that each have a 2z in it. So I'm going to multiply one of them by -1. So I don't know, the first one. So -1 times 1 plus equation 3. So I'm going to rewrite what that means. So I have -2x plus 4y minus 2z equals -4 plus equation 3. And add. So it looks like I've got 2x minus y, z's will cancel, is equal to 4. Okay, so that's good. Now I gotta eliminate z another way. Okay, so looking again, I could multiply equation 2 by 2. And I could multiply, actually I'll say -2. And then I could multiply equation 3 by 5. Because then that will create a -10 and a +10 that I can then eliminate the z with. Alright, so -2 times 2. So I've got -10x plus 6y. -2 times 5 is -10z equals -2 times -4 is a +8. Alright, now 5 times 3, so I've got, okay, 5 times 4 is 20x. 5 times 5 is 25, so -25y. 5 times 2 is 10, which is what I wanted. And then 8 times 5 is 40. And I'm going to add. Okay, so when I add these, I get 10x. I get minus 19y. Z's will cancel, is equal to 48. Okay? Then I'm going to do, I have two equations here. They're each in terms of x and y. I'll probably just solve for y, because that's what's easiest for me here, I think, as a substitution. So if I move the y over, I really have 4 plus y is equal to 2x. So y must equal 2x minus 4. Then, wherever I see a y, I'm going to sub it in. So I've got 10x minus 19 times 2x minus 4 is equal to 48. Okay, 19 times 2 gives me 38. And then 19 times 4, whoops, 19 times 4 gives me 76, so it's going to be plus 76 equals 48. Okay, so this gives me negative 28x. 48 minus 76, negative 28. So x must equal 1. Ooh, all that, and I got x equals 1. All right. So then what you would do is go through and then find y. So you would plug it back in just to save some time. I'm not going to do that. But you go through, plug x into either one of these equations. I guess I can just do it. So I have y is equal to 2 times 1 minus 4. So it looks like y is equal to negative 2. And then once you have x and y, you can really just plug into any equation. So any of these, and then solve for z, which you know is going to be negative 3. All right, so if I go down. For number 8, we're going to solve the system algebraically. So you guys had one like this on your quiz. So you have it already solved for x, so just sub it in. So I've got 2y plus 2 minus 3 squared plus y plus 2 squared equals 25. And I just have to now solve for y. Everything's in terms of y. So I'm going to clean it up. And I'm going to FOIL. Oops, this is 4y squared. So when you FOIL, that's what you would get. Plus okay, so just like so, combine your like terms. Looks like my 4y's will cancel. So now I have 5y squared plus 5 is equal to 25. So 5y squared, and then I'm going to subtract 25 from both sides, so I have minus 20 is equal to 0. So now I've got to solve. So I can factor out a GCF of 5. Oops, this is supposed to be y squared minus 4. So when I solve, this is really dots. So I get y is equal to negative 2 and y is equal to 2. Now don't forget, guys, you have to go and then solve for the corresponding y values. So going back to, I always go back to the linear because it's the easiest one. I'm going to just move it down a little bit. I have x is equal to 2 times y plus 2. So x must equal negative 4 plus 2. So x is equal to negative 2. And x is equal to 2 times 2 plus 2. So x must equal 4 plus 2, which is 6. So if I just write this as a final solution set, I have negative 2, negative 2, and 6, 2. These are my answers. So if I want to check it or solve it graphically, let's just go back and look at this. Keep in mind that this is a line. So if I solve this for y, I have 2y is equal to x minus 2, so divide by 2. Y is equal to 1/2 x minus 1. Okay, so that's a line. It has a y-intercept at negative 1 and a slope of negative, or a slope of 1/2. So it's going to go up 1 over 2. So let's see, can I get a good line here? It's decent. I'll extend the rest of it in the other direction. Okay, so something like that. And then I'm going to graph my circle. Now this circle, it has a center at 3, negative 2. So I'm taking the opposite signs here and a radius of 5. So let's look. 3, negative 2. 1, 2, 3. So here's my center. And then I have a radius of 5. I'll zoom in here. So when I get, that's terrible. When I sketch in my circle, do the best you can, really. Make it look nice, since we're not using a compass. Check out the points where it intersects. This is the point 6, 2, and this is the point negative 2, negative 2. Okay, just a couple more problems to talk about. Writing the equation, giving just a picture. What you really need here is the vertex, which at this point, the vertex here looks like that's at 3, 4. Or sorry, negative 3, 4, because it's in the negative direction. And the p-value, so the distance from here to here, keep in mind the units are 2 each, so p must equal 4. Okay, since it's a parabola that is opening downward, I'm going to use y is equal to negative 1 over 4p x minus h squared plus k, and then plug it in. So this is y is equal to negative 1 over 4 times 4 is 16. times x plus 3 squared plus 4 by plugging in h and k. All right, at the same time, there's a parabola like this where it's sideways. This is your key that's going to be an x equals equation. Since it's opening negatively, it's going to be negative 1 over 4p. Okay, so it looks like my p-value, so let's see. My vertex here looks like it's at 2 and negative 1. So the p-value between these two is 1. All right, now I just have to plug it in. So I have x is equal to negative 1 over 4 times 1 is 4 times y plus 1 squared plus 2. Again, this is h and this is k. All right, so the question is, which parabolas from number 11, so A and B, are congruent to a parabola with this equation? So we know we're going to be looking at this number here. So I have 4p is equal to 16, so p must equal 4. Okay, so congruent means the p-values are equal. So if you look, the only one with the same p-value is A. So parabola A. How do you know they're congruent? I'm not going to write it out, but it's because they have the same p-value. So it says which parabola, I'm just going to say A. Okay, for 13, which parabolas from 11 are similar to the parabola whose equation is this? Okay, it's the same thing as this. Well, how do we know they're similar? Well, all parabolas are similar. So both A and B are similar to this equation, and that's because all parabolas are similar. Okay, so that concludes this review video. I hope it helped. Happy studying!